Morning. So the 7 management tools we were discussing. So already 6 we are covered. So very quickly I will summarize, and then the 7th technique, that is the activity network diagram, we will discuss in this class. So these are all 7 management tools. Already one more 7 is there actually. 7 QC tools, quality control tools, where we studied about Pareto analysis, cause and effect diagram, all these things, check diagram, all these things, they are all 7 QC tools. In the same way, there are 7 management tools which can be used for improving the quality. So this post-field analysis we have discussed in detail. That is the first technique, and nominal group technique. So people, it is just like brainstorming technique. And then affinity diagram. So you will have some scrambled ideas, and then you put them in an ordered fashion. So that is called, that's why the word affinity diagram. And then interrelationship graph. So here we will have many iterations. We will find what is driver and what is outcome. So based on you take any two. So the iteration goes like this. You take any two, for example, A and B you take, and you find out whichever is having the strong influence on this effect. The issues related. So if B, in this case, B is having the strongest influence, so from B you draw an arrow to A. So like that you complete the thing. Finally, you will get the interrelationship graph like this. So from B, all the arrows are originating. So this is the driver, whereas this is the outcome. All the things are terminating. All the arrows are terminating in E, lack of parental examples. So this we know when you have some. So you found out some causes, and you want to find which is the most driving causes and which is the outcome. So these two things we can analyze by means of this interrelationship graph. And then tree diagram. So whatever you keep on, you go to the details. First, increasing workplace suggestion. So there are some 4 suggestions. Create workplace, and this you try to, in detail you try to study. So what we are trying, we can create simple input system, streamline the evaluation, create quick implementation. So like this, finally it will form a tree. So the objective, we have a single objective. Keep on going to the details. Just like a tree will be having so many branches. So that is called tree diagram. And the next thing is matrix diagram. So here, just like that, what we studied in the previous, that is before CAT1, we have seen that house of quality. So where we tried to the customer requirements and the technical requirements, company requirements, we try to match them to find out whether they are strongly influenced or whether they are weakly influenced or moderately influenced. The same way, so here also for any activity, we are trying to find out the purpose of the matrix diagram. So we find out which is more important. So for that, we take some criteria. Just like in this case, we have taken the 7 management tools: affinity diagram, interrelationship diagram, tree diagram, prioritization matrix diagram, PCDC, and activity. So all the management tools we have taken, and we have taken some criteria, 4 criteria, which creativity. So out of this, you see, this is always related. Creativity, affinity diagram, very creative. So here that means there is no relationship. Whereas PDPC, we will see today. So that is having a frequently there is it has something to do with it. So like that, you find out, map each one of them. You try to. So map means triangle means very occasionally. If there is no symbol means that means there is no relationship. Affinity diagram has nothing to do with analysis. So we are not doing any analysis. Whereas interrelationship graph, some analysis we are doing. Tree diagram. So here some analysis is there. There is prioritization also. Only we are doing the ranking. So that is about the matrix diagram. So just like house of quality. So we are trying how they are related, whether they are related or frequently they are related or occasionally or they are not related. So we have some criteria and we try to evaluate the various management tools. So that is the purpose of this matrix diagram. Prioritization matrix, same thing as the matrix diagram, only thing is we give weightage. So for example, the objective here is improving the shipping agency, and we have taken people. What we found out is there are three options. If we want to improve the shipping efficiency, when it comes to people, we can train the supervisor, we can train the operator, or we can have a three-man crew. So this is what they have decided. And we have taken criteria. Which option is quick to implement, which option is accepted by users, available technology, we can low cost, all these criteria, we put some weightage, and finally we get it. So that is called prioritization. There is no analysis here. So that's what this way we are doing. So finally, one thing will come. So we are giving weightage because all are not equally good. So this quick to implement, all are not equal. One of them, so two people will decide which is more important. All are important. Some don't give equality. We are not going to give equality. Some points are very important. For example, quick to implement is very important. So if we decide something, then only the shipping efficiency will improve. So we can give more weightage when compared with the other one. Of course, cost is also very important. Available technology, okay, that can be secondary. So like that, no, we can prioritize. And among the options, we can choose the option based on weightages and other things. So that is called prioritization matrix. And then process decision program chart. So whenever you want to do any activity, this one because I have very few conferences I was an organizer. We conducted a VAT, we conducted a national conference in the year 2017. I was a secretary. So these are all based on the process. We can find out. We can because our idea is mistakes should not be there. So in this case, the objective is to plan the successful conference. So this is planning before the conference, planning the conference. So these are all some of the activities. So there are facilities, presentation. Whenever conference is there, presentation is a very important one. But of course, nowadays we are conducting pre-conference workshops, so many things. Of course, presentation is very vital. Keynote lecture, all these things. And then registration. And we have taken presentation alone, just for simplicity. Presentation alone, there are three issues. So what will happen if the speaker is late? This online, luckily, fortunately, these 2 years, VAT, we have been conducting so many. VAT Chennai is one of the universities. We have conducted around our mechanical engineering, School of Mechanical Engineering. We have conducted around some 10 online conferences. Maybe 3 or 4 people they have conducted. Even this year also, we have planned for 3 or 4 online conferences. Because it becomes easier. Speaker late is not an issue mostly. Because people know once they commit, they will come. If they have to come, means traffic jam, all these things. So speaker is late, you have substitute. So like that, countermeasures. So what if? So we are planning for a successful conference. So that is a process decision program chart. So we are not doing any analysis here. So if the speaker is late, you have some substitute. So that's what many times, if it keynote lecture is not, one of the professor from VAT Chennai will give the lecture. So like that we can do. If the audio visual fails, you have one more, very, very important. This many times, even during the conference, I was taking care of the. So there's so many issues are there, audio visual system, because we are conducting so many parallel sessions. So all audio and visual tools, if they are going to fail, means backup should be. The presentation is too long, means timekeeper, because we cannot give, because there are some people who will talk, they will keep on talking. Sometimes because it is their research, they are very strong in their research. It is very interesting for them. I don't know whether sometimes it may not be interesting for the audience, but because it is their work, they will keep on talking. So we cannot give, but others have to give. So if it is too long, we can have a timekeeper. Every conference, even yesterday I gave a the day before yesterday, Monday, I gave one presentation in one of the conferences in the college. So they gave only 8 minutes. So they were very strict. So there are 160 participants. So they told it's online lecture, online conference. So they said only 8 minutes, 2 minutes for us. So you see, whatever you want to do, please do it in 8 minutes. So that's what. Whatever research, whenever we do PhD, we do our PhD work for 3 years. Finally, when we make a presentation, they are giving only 45 minutes. Late, March the 12th of 2021, I gave my online examination. I defended my thesis now. Not even 3 years. I have been working for 8 years. and they gave me only 45 minutes. So that is there. So if it's too long, you cannot. This way you plan them. So this is called process decision program chart. So this is usually in service. The components, you will not have this type of process decision. So their quality management tool is going to be different. This is mostly used in service industry. So whenever there is an objective, you try to find out what if. So if there is a problem, what is a countermeasure? What is the alternative backup? Nowadays, people are telling you have one plan A, and if plan A, so if due to some circumstances plan A is not working, you have alternative plan B. That's what everybody is telling. So you try for some institution, for example, MBA in IIM. So that is plan A. Plan, if you are not getting that, next plan should, alternate plan should be there. At least there are some institutions, management schools, which are equally popular, but of course IIM is IIM because their salary package is. So that way, this is called process decision program chart. And finally, we have this activity network diagram, and I think this we have covered in operation research. So we will not go into detail. So here, this activity network diagram, there any process will have many activities. So for example, in this case, ISO orientation is one activity, training, development, document development, internal audit, auditor training. So there are some 5 activities. Just for simplification, we have taken some. This process has got some 5 activities, and they will have to be in sequence. And please understand, some of them can be done simultaneously. So for example, first ISO orientation they will do for 4 weeks. ISO orientation they will do for 4 weeks, and then training and auditor training. Training and auditor training we can do for 3 weeks. 3 weeks. And then document development, it will take 12 weeks, and finally the internal audit will take 10 weeks. So here, this early start time and the late start time we can have. Finally, 29th week, everything should be completed. So basically, there are 2 routes here. The there is something called critical path method. So those who are even some 19 BM students, under me also. I don't remember the names in this class. I don't know. Critical path method and program evaluation review technique, PERT and the CPM we have seen. So this activity, longest one is called CPM. So in this case, obviously you'll understand 1, 2, 4, 5 is the longest one, whereas 1, 3, 5 is the shortest one. The longest path is the critical path. Critical path. Please remember, this training and auditor training can be done simultaneously. So this way we are proceeding. So this 4 is for ISO orientation will take 4 hours. This training will take 4 hours. Initially, after completing ISO orientation, then only we can start this training. So 4th hour is the starting time, early start time, late start time. And it is going to take 3 hours. So this way, early start time, completion time. 7 is the completion time. So whereas in this case, you see there is a difference. Now, so this year, it will take 2 hours. Starting auditor training can start after 4 weeks only, and it won't take 2 hours, 6 hours. So this is early start. But since this 19th, after that only this can be. So these these activities are to be considered. This has to be served. So the late start is 17. So instead of 4, we can start at 17 also. Nothing is going to happen. So this way we can plan whenever you have a large number of activities. We can plan our resources. So this auditor training, there is no hard and fast rule. It should start at 4. So the idea is it should be completed when the document development is over. This should be completed. So this can start at 17 because only it is going to take 2 weeks. So 17 plus 2, 19. So this way we can. So that is called activity network diagram, which is very widely used in construction projects and many projects. Now with the help of computers, we can do wonders. So the concept is that early start time and the late start time. Because since we are having some simultaneous activities, all of them need not start at the. So for example, in this case, it need not start at the 4th week. It can very well start in the 17th week. The idea is it has to be completed only after this activity. So this is called activity network diagram. And whenever you have many activities, there will be 3 or 4 paths. In this case, there are only 2 paths: 1, 2, 4, 5. Then 1, 3, 5. But always longest should be taken. That is the critical part. So that is going to be the time. So 1 minute. Hello. Number one. So that is called the activity network diagram. So these are the 7 management tools. So last CAT 1 exam, we had 7 QC tools like Pareto diagram and other things. Here also we have 7 management tools, and they are given what they call Westerfield book. They are given very neat one. Chapter is there for this management tools. The next thing is there is something called CP analysis and CPK analysis. I'm not going to discuss problems, but we will exam, CAT exam, I'll ask some problems. Please try to understand the very simple mathematics is involved here. And in machine drawing, you studied something called tolerance. I don't know whether you remember machine drawing. So whenever there is a drawing, you will have bilateral tolerance, unilateral tolerance, all these things. What is the tolerance? So, for example, the shaft diameter. For example, if you take a shaft diameter, it has to be 25 plus or minus 0.01 mm. So that plus or minus is a bilateral tolerance. If it is unilateral tolerance, only one side you will have. So what do you mean by that tolerance? Tolerance is nothing but it is a permissible variation in the component. So in the component, that is called specification. So we are giving in the specification. But you may ask me the question. We have modern technology, we have CNC machines, we have CNC lathe. Very precisely we can manufacture exactly 25 mm we can make because without the operator intervention, now CNC lathe is available, program can give, and we have very excellent controllers, everything. It is a very precise machine. But the problem is now, if you want to make exactly 25 mm, it is a bit costly. That is why if you keep tolerance now, and many times now, it is we can some type of variation is acceptable because cost is very less. Instead of going for a very high-end CNC machine, we can go for an ordinary CNC machine where the precision levels are bit low. Also, we can go because the cost will come down. Even cutting tool cost will come down, equipment cost, everything will be there. So that is why sometimes no, it is acceptable. So that is called specification. So we can, some type of variation is permissible. Some type of variation is permissible. That is called specification. And this specification we are not covered so far when we have seen the control chart. So this control chart, we had some limits, UCL and LCL. I think last 1 week we have been discussing about the control chart. One we call upper control limit, UCL, and then lower control limit. And if you remember, this upper control limit and the lower control limits, they are based on averages. So if you have taken Monday's class, if you remember, we have taken within a subgroup how we are considered a deviation, and so all these things, that is statistical quality control, they are based on 2 concepts. One is average or mean, the other one is standard deviation. So this entire limits, whatever calculation in the control chart, upper control limit and the lower control limit, they are based on averages and explain. So now this distribution will be like this. So when we have taken the control limits, so this is the average line, this is X bar, this is X bar, and our mu. This one, that's a very slight difference between mu and X bar. That means we can do it in 2 ways. One is we can take samples and we can do the analysis. Another way is by doing in a population. So that's why in one, I don't remember properly. One thing they will use the word, they will use the symbol mu, and sometimes they will use X bar. I will use them interchangeably. But both of them, they are meaning average or mean. So this distribution, so this relationship is very important. So when you draw the control charts, the distribution is like this. And if the point is lying outside the control limit, I told you there are some 4 rules I told you. If the point is lying outside, even if one point is lying outside the control limit, the process is out of control. That means there is a problem. Either it can be the operator is unskilled, the raw material, there is a defect in the raw material, or there is a problem with equipment, or there is a problem with power, or there may be some assignable causes. There may be assignable causes or inherent causes. Now, the next thing is we come to the thing specification. Now USL, so UCL, don't confuse. UCL is upper control limit, LCL is lower control limit. That is for control chart. So now we are discussing process capability. USL is nothing but upper specification limit, lower specification limit. So these specification, they are optional locations. So these, whatever these control limits, they are based on data. So from average, we are finding 1 sigma, 2 sigma, 3 sigma. So they are based on the samples, whatever population samples. We are finding out what is going to be the 3 sigma plus 2 sigma, 1 sigma, all these calculations, and then we are plotting the points. So here the location is decided by the analysis. Whereas this specification is decided. So 25 plus or minus 0.1 mm. So this has nothing to do with average. Please remember, this has nothing to do. So that relationship between specification, limit, and how the points are distributed. So that is what, there are two parameters. One is called the CP, another one CPK. So they will give a measure, because control chart will never say anything about specification. So it will all whatever analysis they are doing from control chart is based on average and sigma. It will not take specification into account. So now considering specification, thus unnecessarily we need not waste the money. So we have some specifications, 25 plus or minus 0.1 mm. That means the diameter of the shaft can lie between 25.1 and 24.9. So it can be between 24.9 and 25.9. Any value is acceptable. So this is optional location. It has nothing to do with the what you call this sigma average. So these two, upper specification limit and the lower specification limit. So in between we will have a distribution. And here there are two important parameters which can be analyzed, and we can say whether the process is conforming to the specification or whether it is in control or out of control. So that is called process capability. So the process capability, not only the sigma and the mu, it also considers the specifications, and it decides whether the process is in control. So there are two things, CP and CPK. So that's what we will discuss. And you should, in the examination, there are very simple calculations. You should know how to find out this CP, and there are two indexes actually, CP and CPK. So the relationship of the process capability and specifications are shown in the figure. Tolerance, very important, machine drawing study. Tolerance is the difference between upper specification limit, USL, and the lower specification limits. So that is, indirectly I told you, that is the permissible variation. So upper control 25.1, the 24.9. So that difference is called tolerance. So this is upper specification limit and the lower specification limits. So process capability and tolerance can be combined to form a capability index, CP, and one more is there, CPK. Next slide I'll show. So this CP is given by USL. So this has to be given in the problem. If at all, the specifications has to be given. So USL will be there, LSL will be there, and you subtract them, you get the tolerance. That divided by 6 sigma. 6 sigma is the process capability. That is called capability index. So CP is nothing but USL minus LSL divided by 6 sigma. And we know sigma is the 6 sigma. How to find out 6 sigma? I will explain. I think I'm not having it in the PPT, I'm sure. So now what is the index? If capability index is greater than 1, the process is capable of meeting the specification. So there are two things. First thing is whether the process is in control or out of control. Next thing is whether it is capable of meeting the specification. So this value should be more than 1. I am next slide. I will show some diagrams where you will understand why it is meeting the specifications. So specifications also, they are very important. So sometimes one side it will not meet the specification. The process will be in control, but it will not be meeting the specification. So that type of problem is also there. So if the index is greater than 1, process capable of meeting this. If the index is less than 1, so that is a basic rule, CP. Whereas CPK, I think it is 0.67. So if it is greater than 1, the process is meeting the specification. If it is less than 1, obviously it is not meeting the specification. So because the processes are continually shifting back and forth, is CPL 1.3. So even not even 1. Some companies they say 1.33 has become a de facto solution. So 2 also we can go. So greater the better. CP, the value, that capability index, if it is more than 1, 1.52, that is fine. So we should strive to make the capability index as high as possible, as large as possible. So this is still talking about. Now I'll stop. I'll show that how to calculate that sigma. This is very, because I'm going to give a numerical example in the examination, category examinations. So now, for example, there are some 25 subgroups, each of size 4. This is small n. 4 is small n. G, 25 is G. That is number of subgroups. Total 100 measurements we have taken. For each subgroup, for each group, I'm finding the range. And the range I told you, the maximum minus minimum. Minus minimum, that is the range. For each subgroup, there are 4 values. Whichever is maximum, whichever is minimum, you subtract, that is the range for each subgroup. Then 25 range values will be there. You add them, divided by 25. That is sigma R divided by G is 25. Okay, you will get the average range. And then calculate and estimate the population. That's what very important. We are not using that usual sample deviation. The sample standard deviation is given by the formula sigma x minus x bar whole square divided by n minus 1. So that we are not. That is for sample standard deviation. So this is a population standard deviation. This may not give accurate value, but it's good enough value. So this R bar divided by D2, which is a constant, which is given in an appendix value. For small n, it is 2.059. So if at all it is mostly, it is going to be a closed book examination. I don't know. It is going to be an offline examination. Cat 2 is going to be an offline examination. So if at all they are allowing material, if it is open book in the offline, I think you need to bring this table. You need to bring the table. I'll tell during the exam. Or otherwise, I will give this value for each subgroup size. What is going to be the value of this? So this is a constant. So this average range divided by this constant will give sigma. So this 6 sigma is called the process capability. So now this is going to be very important. So more than one CP, then only the process is meeting the specification. Now there is another thing. Capability, this does not measure the process measurement in terms of nominal or target value. There is one more thing which is called CPK, which is given something like that. Minimum USL, that is upper specification limit minus X bar average. Or minimum, there are 2 values, whichever is minimum you have to take, and then divided by 3 sigma. X bar you subtract by LSL and you divide by 3 sigma. So this is going to be very important. In the coming slides now, CPK, how we are getting. So minimum of USL minus X bar or X bar minus LSL, you divide by 3 sigma. There we had 6 sigma, there we are having 3 sigma. Now there are 3 cases. So in the first case, listen to me very carefully. Now it is like this. This is one. So this is X bar. In the middle, we are having the average X bar in the middle. 1 sigma, 2 sigma, 3 sigma, and then 4th sigma also is there. So this is 3 sigma this side, X bar minus 3 sigma, X bar plus 3 sigma, so 6 sigma. But specifications is lying outside. Specifications are lying outside. LSL, lower specific. So this is the first case. LSL is lower specification limit, USL is the upper specification limit. Now the CP is given by USL minus LSL divided by 6 sigma. I think sigma is missing. Now USL minus LSL, you see USL, and there are 8 sigmas. 1, 2, 3, 4, 5, 6, 7, 8 sigmas is there. USL minus LSL, there are 8 sigma, and 6 sigma. This 6 sigma, 8 sigma by 6 sigma, we are giving 1.33. That means the product is missing this. Very obviously, even without understanding this concept, you will tell it is within the specifications. Now, within the specification, the process, all the distribution of points, it is within the specification. That is, the process is meeting the specification. And the next thing, if you see, you will have USL. In this case, it is like this. We are getting here also, we are getting 1.33. The reason is 8 sigma here. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So 8 sigma by 3 sigma. This is also, but this is different from here. but you say CPK value changes. So please remember, CPK value 1 is the de facto standard. If it is less than 1, it is not meeting the specific. If it is less than 1, it's not meeting that. So 1 means it's fine. Some organizations say 1.33, 1.33. But if CP value, it should be more than 1. Here also 1. If it is less than 1, there is a problem. There is a problem. So here, how to find out CPK? Minimum of USL minus X bar or X bar minus LSL. Then you divide by 3 sigma, not 6 sigma. So here, I'm taking from X bar, USL to X bar, USL to X bar, 1, 2, 3, 4. 1, 2, 3, 4 sigma minus 3 sigma. I told you when CPK means 3 sigma. So USL to X bar, it is 4 sigma divided by 3 sigma, 1.33. Same way this side also. This side also, X bar to LSL, there are 4 sigma divided by 3 sigma, you will have 1.33. Whereas in this case, listen to me carefully. In this X bar, from X bar to USL, 3 sigma by 3 sigma. 1, 2, 3. 3 sigma by 3 sigma, you are getting 1 value. Because 1, 2, 3. X bar to USL, there is 3 sigma. Divided by 3 sigma is 1. Here, 1, 2, 3, 4, 5. So 5 divided by 3. 5 sigma divided by 3 sigma. And we have to take the minimum value. So 1 is the CPK value. But of course, this here they are saying it is here also. It is here also. It is lying within the specification. In this case also. So both the process. Case 1, both the process. You will understand the process is lying within the specification. So the process is meeting the specification. Now case 2. We will take case 2. Case 2. Here you see 6 sigma LSL minus USL 6 sigma, and this is 6 sigma is there 6 sigma by 6 sigma 1. So CPK X bar to USL is also 3 sigma by 3 sigma 1. This side also 3 sigma by 3 sigma, it is 1. So CPK is also 1. But here there is a difference. Here up to here only. So the process is up to here only. So in this case, CP value is 1. How do you say the CP value is 1? From USL 1, 2, 3, 4, 5, 6. So 6 sigma by 6 sigma 1. CP value 6 sigma. USL to LSL 6 sigma by 6 sigma 1. When you come to capability, you see only 0.67 plus 2 sigma. This is not there. Specification is coming inside. Specification is coming inside. So CPK value is less than 1. So that means the process is not meeting the specifications. Because outside the upper limit, some of the points is coming outside the upper. So even though CP is fine, CP is 1, CPK is less than 1. You very obviously will see that. So here it's not there. So CPK value, minimum value, X bar to USL, it is only 2 sigma divided by 3 sigma is 0.67. And the process is not meeting this specification. One more case is there, third case. Third case. In this third case, you will see control limits. Obviously, both we can tell it is not meeting the specifications. You see, there is a darkened thing. So upper limit to lower limit only 4 sigma, 1, 2, 3. So 4 sigma divided by 6 sigma, 0.67. CP value is 0.67. And here also it is 0.67. USL to LSL, CP value is 4 sigma by 3 sigma, 6 sigma, 4 sigma by 6 sigma. We are getting 0.67. Now the process is not meeting the specification because CP value is less than 1. CPK value minimum I'm finding. So this is 2 sigma. X naught to USL is 2 sigma by 3 sigma, which is 0.67. Here it is 3 sigma by 3 sigma 1. So minimum you have to take. Yeah, sorry, here also, I'm sorry. LSL to X bar, here also it is 2 sigma by 3 sigma. So 0.67. Both are equal. Here in this case, only 1 sigma, 0.33. X0 to USL, 1 sigma by 3 sigma, 0.33. Here from lower limit, 3 sigma by 3 sigma, 1. Lower value we have to take 0.33. So this case 3, the 2 plus. But obviously we can see specification limits. Outside the specification limits, we are having some distribution of points. The averages, whatever control limits are coming outside the specification. Even without doing the analysis also, we can tell that it is the process is out of, it's not meeting the specification. So this analysis, I will be asking some simple problems. Only thing, these diagrams you must know. Some data I will take. From the data, you must tell. From CPK, we have to calculate CP and CPK values, and you must say whether the process is meeting the specifications or not. From control chart, you can very well tell the process whether it is in control or out of control. So the basic idea is you need to know the relationship between control limits, distribution of points, and specifications. So specification will come only in case of this CP and CPK analysis. So that's what you have to be very careful. Simple. You understand the concept. Whatever I am asking is going to be very simple. Some values I will use. So these are all some comments about CP and CPK. CP value does not change as the process center changes. Sorry. So I will show. The CP value does not change as the process center changes. So first comment. So the CP value does not change as the process center changes. Diagram you see. If I am shifting the process center, nothing will happen to the CP value unless the specifications are same. If the X bar instead of this, if I am having the X bar, only everything will be shifted. Everything will be shifted. So the comment is the CP value does not change as the process center changes. So it depends upon sigma, 3 sigma and plus 3 sigma. So center is changing, nothing will happen to the CP value. CP and CPK will be equal when the process is centered. So I will throw these cases. So in this case, the value is, so here it is centered. So 1, 1 equal. It is not centered. You see here, lesser. If the process is centered, CP will be equal to CPK. Here the process is not centered, so they are not equal. Next case we will see. The process is centered here. Process is centered, CP is equal to CPK. The process is not centered, CP is not equal to CPK. Case 3. The process is centered. Again, here also, both sides, it is centered. So 0.6107. So here it is not centered. So CP will not be equal to CPK. So with this, I will stop for this class. I want to give some 2 announcements. So number 1 is I have completed the revaluation. So just you can pick up. I have made some changes. I think 8 students applied for revaluation. And I think for all of maybe 1 student, all the remaining 7 students, I made some changes. So you can revaluation. It's available in Codetandra. That is number 1. The second thing is the assignment. Assignment DA1 has to be submitted on or before. So there is no more data. Almost I'm going to give the second assignment. So no more extension. Please, all of you plan for another 4 days are there. 13th of March, night 12 o'clock, midnight 12 o'clock is the last time. That is 11 o'clock, 59 minutes, the time I have given. So before that, you please submit the assignment number, digital assignment number 1. So please, that is going to be important. So please, deadline is going to be because I have given deadline so much time I have given, so much extension I have given. So please complete the assignment and you submit in the Moodle on or before 13th of March. And then revaluation is completed in Codetandra. Now I take attendance.